Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1. In the last few videos, we have discussed from question 1 to question 20, and today's lesson, we will start from question 21. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 21 says a child slides from rest down slides A and B as shown above. The slides are the same height and the coefficient of friction between the slides and the child is the same. Which of the following compares the change delta K in the kinetic energy of the child and change delta U in the potential energy of the child earth system for the two slides? So this question is just simply based on conservation of energy. If your concept of conservation of energy is clear, simply we can answer this question. In this case, you can see first of all they have the same height. It means they have the same potential energy. So the change in potential energy is the same. So if work done by friction is greater, it means that change in kinetic energy will be lower. If the work done by friction is smaller, change in kinetic energy will be greater. So simply we can answer this question like this. Now let me explain you this question in detail. So if you want to understand this whole concept in detail, so you can see here these two slides, they have the same initial height. Now we will use conservation of energy. So first of all, simply we can say initial energy of the system means initial total energy. This one has to be equal to total final energy. Initial energy we have only, that is GPE initial. So if you wanna write down in detail, we can also write down this one in detail, so maybe it will help you to understand the concept better. So we have initial GPE, we can say GP initial, plus we can say we have initial kinetic energy. This one has to be equal to GPE final plus kinetic energy final plus work done against friction. Now we can rearrange this one, so we can write down GPE initial minus we have GPE final. This one has to be equal to kinetic energy final minus kinetic energy initial plus work done against friction. Now we can write down this one in terms of change in potential energy. We can say delta GPE, this one has to be equal to delta KE plus work done against friction. In this case, change in GPE is the same. So if the work done is greater, we can rewrite this one. We can say this is delta KE plus force of friction times the distance travel. If you look at A, in this case distance travel is only this much, and in this case the distance travel is much longer. So this distance travel is longer, but force of friction is the same. As friction in this case is the same, and if distance travel is longer, it means that work done against friction will be greater. If work done against friction is greater, it means the change in KE will be lower. So this change will be lower. So in this case, delta K will be lower because work done against friction is greater. And in this case, delta KE will be greater because work done against friction is lower. So the change in delta K for A is greater. So first one is not possible, second one also incorrect, third one can be possible. Change in delta K is greater than change in K for B. And so this one is correct because this is the same. This is correct, but this one is incorrect. So the answer for this question is C. Question 22 says a student is observing an object of unknown mass that is oscillating horizontally at the end of an ideal spring. The student measures the object's period of oscillations with a stopwatch. The student wishes to determine the spring constant of the spring using the measurements of the period of oscillations. Which of the following pieces of equipment would provide an other measured quantity that is sufficient information to complete the determination of the spring constant? So for this question, it is given to us. We have unknown mass that is oscillating at the end of an ideal spring. So this is our spring mass system. We can also imagine this one. If we pull this one to the right, to the extreme position here, and then we let it go, it will start oscillating like this, and then it will return to this extreme position. It will oscillate between these positions. So you can imagine spring mass system is oscillating horizontally. So we need to understand how we can determine the time period of spring mass system. Time period of spring mass system, simply T is equal to 2 pi m over k. M is the mass attached at the end of the spring. This mass. This is not mass of the spring. In this case, we are talking about ideal spring. Spring is massless. Spring has no mass. So only you need to take the mass at the end of the spring. So this is that mass, and k is spring constant. So if we need to determine spring constant and we have this quantity already, so simply we need m, and to measure m we need balance. So we can measure m with the help of balance. So the answer for this question has to be C. Question 23 says, using a number of measurements, the student determines the following: spring constant, mass of object, amplitude of oscillations, and maximum speed of object. And we need to determine total energy of spring mass system. So the total energy of spring mass system we can determine using different ways. One way to determine total energy of the spring mass system is we can simply calculate by EPE, means total energy of the system is equal to EPE. So we can use 1/2 kx square. So in this case we are talking about the maximum energy, means the total energy. So this is the amplitude. Now if we plug in values, we can find the answer, because we have value of k is given to us, that is equal to 85 newtons per meter, and we have amplitude of oscillations that is equal to 0.30 meters square. If we solve this one, our answer will be around 3.8 joules. So the answer for this question has to be B. But you can also calculate total energy of the system when it is at equilibrium. Then total energy will be equal to Ke max, and we can calculate simply by 1/2 mv max square. So in this case we have mass attached with the spring, and the value of mass is given, that is 0.50, and we have V max, that is 3.9. So we have 3.9 square. If we solve this one, we will also get about 3.8 joules. So this is the answer. Question 24 says, while the object is continuously oscillating, the student determines the maximum speed of the object during two oscillations. The first speed is 3.5 meters per second, and the second speed is 2.7 meters per second. Which of the following could account for the decrease in the object's maximum kinetic energy? So for this one, we need to understand first of all a little bit more about our horizontal spring mass system. In this question we are talking about horizontal spring mass system, when the mass is oscillating horizontally. So this is the equilibrium position, so we can write down this is equilibrium. So this is equilibrium. Then we pull this spring to the right, so you can imagine we pull this one to this position. So this is the extreme position, and in this case this is the maximum displacement. So this is the amplitude, or we can say this is x max. And at this point, total energy of the system, this will be equal to EPE, and EPE is maximum, and this is equal to total energy of the system. But if you look at equilibrium kinetic energy is maximum, and this is the total energy of ideal spring mass system. And also we can draw this mass here when the spring will be compressed. So at this point is also true, EPE will be maximum. So we can say EPE will be maximum, and this is equal to total energy. But at this point, KE will be equal to 0, and here KE also will be equal to 0. Now we need to understand the relationship between them. So if you look at equilibrium, you can see kinetic energy is changing into EPE when this mass is moving to the right, and vice versa is true when the mass is moving to the left. So EPE will change back into kinetic energy, and when this mass is moving from equilibrium to the left, kinetic energy will change into EPE, and when it is moving to the right, EPE will change into KE. So these are the main concepts you need to understand. If this is clear to you, now we can go to given options. For option A, it is given to us energy was transferred from the object to the spring, which increased the maximum potential energy of the spring. This is true for ideal spring mass system. All the time this is happening, but this is not the reason why speed is decreasing. Maximum speed, we are talking about maximum speed, very important point. Maximum speed will not decrease when energy is transferred to potential energy. So energy will be transferred into potential energy, but when object will come back to equilibrium, maximum kinetic energy again will be the same if there is no friction. So it means this one is incorrect. The energy was transferred from the spring to the object, which decreased the maximum potential energy of the spring. This is also incorrect. As energy was transferred back and forth between the object and the spring, a greater average share of the energy became potential energy of the spring. Incorrect. The object spring system lost energy to its surrounding. So if maximum speed is lower, it means the system has lost energy to surroundings. So the answer for this question is D. So this is, you need to understand how energy change in spring mass system. So when object is at equilibrium, it has only kinetic energy, and when it is at extreme position, spring mass system has only EPE because the mass is not moving. So all the energy has been converted into EPE, and vice versa is also true. So this is how you need to understand. And if the maximum speed is decreasing, it means there are resistive forces, mean there is friction, there is air resistance. Due to those external resistive forces, system is losing energy. For question 25 and question 26, it is given to us a crate is on a horizontal frictionless surface. A force of magnitude F is exerted on the crate at an angle theta to the horizontal as shown in the figure above, causing the crate to slide to the right. The surface exerts a normal force of magnitude Fn on the crate. As the crate slides a distance d, it gains an amount of kinetic energy delta k. While F is kept constant, the angle theta is now doubled but is still less than 90 degrees. Assume the crate remains in contact with the surface. We need to find out how does the new normal force exerted on the crate compare to Fn. So we can simply draw another line here. So we increase the angle. So angle is double now. So simply we can draw like this. So in this case, it is given to us this angle is double. So this angle is equal to theta. We need to compare the new normal force with the old one. And so in both cases, we can write down first of all case 1, and we can also write down second case, case 2. For case 1, we need to understand mg. This is the force that is acting downwards. We can also draw the free body diagram. We have mg that is acting downwards, and there will be normal reaction force that is acting up. This is the n, and there is upward force that is F sine of theta. Means we can resolve this one into two components. So this is the force that is acting upwards. Normal reaction force is also acting upwards. So in this case, we have Fn. This is equal to F sine of theta. In the second case, also mg is equal to Fn nu. So this is Fn nu, plus we have F sine of theta. So we can say this is theta 1 and this is theta 2. As in the question it is given to us that theta 2 is greater than theta 1, it also means that sine of theta 2, this is greater than sine of theta 1. If sine of theta 2 is greater, means if this quantity, this increase and this remains constant, it means overall this will increase. So overall this quantity will increase. So this one has to decrease because mg is the same. So F nu has to be lower than Fn. So simply we can say in this case Fn nu, this one has to be lower than Fn because there is more upward force on the crate. So crate is pushing not as hard as before. So the answer for this question should be B. A is not correct because it's telling you is greater, this is telling you is less, so this is correct. This is telling you is equal, this is incorrect. The new normal force is greater or less than Fn depending on the value of theta. Value of theta is already given to us, that value of theta is greater than before. So this is also incorrect. So this is incorrect. This one is correct and this is also incorrect. Question 26 says, as the crate slides a distance d, how does the nu gain in kinetic energy compare to delta k? So this question is simply based on work energy theorem. So we can write down work done by the net force F net. This is equal to change in kinetic energy, and F net we can again rewrite F net times d. This one has to be equal to delta k. F net in this case is equal to F cosine of theta times d, and this is equal to delta k. As angle increase in this case, so we can write down angle increases. If theta increases, then cosine of theta will decrease because cosine of theta is equal to 1 is maximum when theta is equal to 0. So we can say cos of theta, this is maximum, this is equal to 1 when theta is equal to 0. When theta is equal to 0, cosine of theta is maximum. As angle increase, cosine of theta will decrease. As cosine of theta means this quantity decreases and F is the same, so it means overall this quantity means the horizontal component of the force will decrease, and d is the same. We are comparing for the same distance, so delta k has to be lower. So the answer for this question also has to be B. The nu gain is less than delta k. So the answer for this question is B. Question 27 says, a block on a level surface is attached to one end of a spring as shown in the figure above. The other end of the spring is attached to a wall. There is friction between the block and the surface. A person displaces the block from its equilibrium position and releases it. Which of the following shows the mechanical energy E as a function of time for the system that includes only the block and the system that includes the block and spring? Simple question, just based on conservation of energy, and we have discussed all those concepts in the previous questions. If you have understanding of those concepts, you can answer this question, but still there is a tricky part in this question. We need to understand that one. So in this case, you can also imagine if we displace this one to the left, it will be oscillating between these two extreme positions. So at this point, kinetic energy will be maximum, so we can say Ke will be maximum. At this point, Ke will be equal to 0, and at this point Ke also will be equal to 0, and at this point EPE will be maximum. So EPE will be maximum. So for this question, we need to find out mechanical energy as a function of time for the block only. So we can write down here E block. Energy of the block, the mechanical energy of the block, only equal to the kinetic energy, but energy of the block plus energy of the spring This is equal to kinetic energy plus this is equal to EPE. So in this case, kinetic energy magnitude will increase when it is moving towards equilibrium. When it reach equilibrium, it will be maximum, and then it will start decreasing, and kinetic energy will be zero when it is at extreme position. So it simply means that kinetic energy of the block, it will be oscillating. So this one will be oscillating between 0 and maximum value, and maximum value each time will go down because there is friction. So there is loss of energy. So it will be oscillating, and K max always will decrease. So K max will keep on decreasing. So these 2 points we need to understand about the block. So how about energy of the block and spring? So this is the total energy of the system. Total energy of the system will not reach 0 and then increase. Mean it will not oscillate. It will just keep on decreasing due to resistive forces. Finally, when this energy becomes 0, it means system will just stop. So it will not oscillate. It will not oscillate. This is the main concept you need to understand. Total energy will not oscillate. Total energy will just decrease exponentially. So we can say decreases exponentially, but it will not oscillate. Decreases exponentially. So these are the points you need to understand. If these points are clear to you, now we can find the answer. Total energy will not oscillate. So it means this is incorrect. Total energy remains constant. This is incorrect. Decreases exponentially. This can be possible. This is telling us energy of the block remains constant. Energy of the block also will decrease, and also it will oscillate. So this is not correct. So answer is D for this question. So kinetic energy is oscillating, you can see, but the peak is always lower than before, means system is losing energy, and total energy of the system just keep on decreasing exponentially. So the answer for this question is D. A beautiful question, little bit tricky one, but if you have some understanding of conservation of energy for spring mass system, is very easy to figure out. Question 28 says a transverse wave is traveling on a string. The graph above shows position as a function of time for a point on the string. If the frequency of the wave is doubled, what is the new average speed of the point? So in this case we are talking about speed. So simply we can say speed is equal to distance traveled by the point in a certain period of time, means distance divided by time. But for this question it is given to us that frequency is double. If frequency is double, it means time period has to be half. So we can say f nu, as f nu is equal to 2f. So it means the time period, so this has to be t by 2, means t nu, this is half. So we can say t nu, this one has to be half, t by 2. So time period simply you can read from here. We have that is equal to 0.5 divided by 2. So the new time period is equal to 0.25. So we can write on here time period that is equal to 0.25 second. And in one time period, this particle, the total distance traveled by the particle in one time period. So particle, let's say it start from here, it will go up. It will travel 0.6 meters, 0.6 meters. And then this particle will come down and it will travel again 0.6 meters. Then this particle will go down, it will travel again 0.6 meters. And then finally it will come back to equilibrium position again. So it will travel extra 0.6 meters. So total distance traveled in this case is 4 times 0.6 meters, and this is equal to 2.4 meters divided by, we have 0.25 second. So the final answer means the final value of the speed, this will be equal to 9.6 meters per second. So the answer for this question is D. A beautiful question, very nice question about wave. how to calculate speed of the particle. Question 29 says Alan and his friend are on opposite sides of a large room. When Alan says something to his friend does not hear him. So Alan repeats the message louder. Louder is very important. And his friend now hears it. Which of the following could be different about the second sound wave compared to the first that allows his friend to hear it? So in this case, it is given to us the second sound is louder, medium is the same, so speed is the same. As the second sound is louder, so we can say loudness is linked with amplitude. If the sound is louder, it means amplitude of the sound is greater, or we can say maximum displacement is greater. So the second sound has higher or greater amplitude, or we can say greater displacement. As this is louder, so amplitude of the second sound wave is higher. Now if you look at given options, for option A, it is given to us the second wave travels to his friend more quickly, means speed is greater. Speed depends on the medium, and it also depends on type of the wave. If type of wave is the same, medium is the same, speed is the same. So this is incorrect. The second wave reflects more of the walls. In this case, walls material is not changing. Walls material is the same, and geometry of the walls is also the same. Geometry of the room is also the same. It means reflection is also the same. So this is also incorrect. The air molecules disturbed by the second wave undergoes a greater displacement from the equilibrium, means higher amplitude. So this one is correct. Question 30 says two strings differing only in length are attached to the same oscillator as shown in the figure above. Both are fixed at the other end and are under the same tension. The oscillator creates a transverse wave and is adjusted to the lowest frequency that creates a standing wave on the shorter string. Which of the following explains why there will not be a standing wave on the longer string? If you look at given options, for option A, it is given to us the waves travel at slightly different speeds on the two strings. Speed of wave on a string depends on two factors. One is tension. In this case, tension is the same. It is given to us tension is the same, so this factor is the same. And second is the linear density. If strings are the same, it means they have the same properties as well. So linear density is also the same. So the speed in these two strings will be the same. In the speed of the waves on these two strings will be the same. So this option is incorrect. Option B, an oscillator frequency that results in a standing wave on a string of one length cannot result in a standing wave on a string with a different length. This option is also incorrect, because one frequency, if we can create standing wave on one string, a different harmonic can produce a standing wave, different harmonic. So different harmonic can create a standing wave on other string if lengths of these two strings are in appropriate ratio, then it is possible. So this is also incorrect. The amplitude of the wave does not match the boundary conditions for strings of different length at the same time. This is also not correct, because amplitude only affects the amplitude of resultant standing wave or height of resultant standing wave. So this option is also incorrect. Option D, the wavelength associated with the given frequency does not match the boundary condition set by the length of the longer string. So this option is correct. So that's the reason stationary wave will not produce, because they are not in appropriate ratio. If they have appropriate ratio, then there will be standing wave.